All right, second video on rational functions is finding equations of vertical and horizontal asymptotes. All right, so here's a function we looked at last time. This was f of x equals x plus 5 over x minus 3. Okay. And we saw that there was that vertical asymptote at x equals 3 and the horizontal asymptote at y equals 1. Okay, and we talked about how the vertical asymptote had everything to do with division by 0, but that the horizontal asymptote was a little bit different. All right, so let's figure out how to find vertical asymptotes first. And like I said, this is just going to be looking for a division by 0. So to find the vertical asymptotes for a rational function, we set q of x, it says q of x is our denominator, equal to 0, and then solve for x. All right, so we'll just do that for a couple of functions. Let's see. There we go. Okay, so we're going to find the equation of the vertical asymptote for this function, 3x minus 3 over x squared plus 3x plus 2. All right, so all we have to do is set that denominator equal to 0. For vertical asymptotes, it does not matter what the numerator is doing. You only care about what the bottom of the function is doing. So we're going to take x squared plus 3x plus 2 and set it equal to 0. And that equation is a quadratic equation. So you can choose to solve that however you like. We have factoring and the quadratic formula. I guess you could try to complete the square on that one. It wouldn't be too pretty. All right, but this one actually factors pretty easy. However you do your factoring, go ahead and factor it. X plus 2, x plus 1. And then we set those two factors equal to 0. And that little shortcut trick that we had for polynomials will still work here. When we set x plus 2 equal to 0, and x plus 1 equal to 0, both of these require subtraction to solve. So we get x equals negative 2 and x equals negative 1. And again, if you want to use the shortcut that you see x plus 2, you can just change that to x equals negative 2 and change this one, change the sign, you'll get negative 1. That trick is still good for this. All right, and you could go over to Desmos and graph that function, 3x minus 3 over x squared plus 3x plus 2, and you'll see right at negative 2 and negative 1, it's going to have a break, those vertical asymptotes. All right, so let's try this one. Okay, so this time I got x plus 2 over x cubed minus 5x. Again, we don't care about the x plus 2. The x plus 2 has nothing to do with the vertical asymptotes. Vertical asymptotes just want us to take the denominator, how about a cube, and set it equal to 0. All right, and this equation is just like the polynomials when we were finding the zeros. If you can do a greatest common factor factoring, that's what you want to do. So I can factor out an x out of both of those terms. All right, and x squared minus 5 doesn't factor when you try to factor it, like this. You're not going to be able to find factors to go there. Okay, so, but that's okay, because if I just treat these two factors and set them equal to 0 by themselves, I get x equals 0, x squared minus 5 equals 0, and we can use square roots to find the solution to this x squared minus 5. So add 5 to both sides, and because there's no x term, since there's no x term, we don't have to worry about factoring. I can just go ahead and take square roots. Okay, the square root was my idea. I took square root of both sides, so I need to say plus or minus the square root of 5. And I don't need to make that into a pretty number. I don't need decimals. I don't need to grab my calculator. We'll just leave it as the square root of 5. So this function has 3 vertical asymptotes. It's got x equals 0, x equals, let's write them out as separate equations. X equals the square root of 5, and x equals negative square root of 5. All right, and again, if you're curious what a function with 3 vertical asymptotes look like, you could head over to Desmos and graph x plus 2 over x cubed minus 5x and see what it looks like. All right. Okay, so that's vertical asymptotes. For horizontal asymptotes, I mentioned the rule for horizontal asymptotes is not as obvious, just as looking at the function. And we're going to have to borrow a little bit of a rule from calculus. So instead of teaching you calculus, I'm just going to kind of skip to the punchline and tell you how to find them. And the important thing for finding horizontal asymptotes is to compare the degree on top to the degree on bottom. Okay, so remember, degree is a polynomial word. Our degree is the highest exponent. Okay, so remember we had degree 4 polynomials, degree 3 polynomials, a quadratic was a degree 2 polynomial. So we're looking for the highest number on top, the highest exponent on top, and the highest exponent on bottom. Okay, so highest exponent, not coefficient, but the highest exponent. All right, and when we compare them, we've got 3 things that can happen. Okay, if the degree is bigger on bottom, then the horizontal asymptote is going to be y equals 0. Okay, so it wouldn't matter if it was x squared and some stuff over x to the third, or if it was x squared and x to the 153rd. Okay, if the degree on bottom is bigger than the degree on top, then the horizontal asymptote will be y equals 0. If the degree is bigger on top, then there is no horizontal asymptote. Okay, so that was that one, the last example that I graphed in the first video where there was that slanted asymptote. That's where you get no horizontal asymptote if the degree is bigger on top than it is on bottom. And then the only other thing that can happen would be if you had both degrees the same. So if both of the degrees are the same, you're going to divide their leading coefficients. Okay, so if I had an x squared term on top, and who cares what else? An x squared on bottom, and who cares what else? Whatever the coefficients were, like if there's a 5 here and a negative 2 here, because they're the same, we're just going to divide those leading coefficients to find the horizontal asymptote. Okay, and that seems like a lot to remember, these big long sentences, these 3 different things. Okay, so we have the world's dumbest mnemonic device coming to help you remember how to find horizontal asymptotes. Okay, which is Bobo, Botno, and Basdic. Okay, so I've highlighted the letters that those stand for. Okay, so this means if the degree is bigger on bottom, then the horizontal asymptote is y equals 0. So that's where the second O in Bobo comes from, y equals 0. If the degree is bigger on top, so the bot stands for bigger on top, then no means no horizontal asymptote. Okay, and the last one is Basdic. Both are the same is the BAS, and then DC is for divide coefficients. All right. So again, these rules come from concepts in calculus, and so they're not going to make any kind of intuitive sense when you look at the function necessarily. All right, so let's just get some practice using those rules, Bobo, Botno, and Basdic. Okay, so we're going to find the equation of the horizontal asymptote. And again, the rule is that we're going to compare the degree on top to the degree on bottom. So I'm going to take the highest exponent on top and the highest exponent on the bottom. And we're going to decide, is the degree bigger on top, bottom, or the same? And since they're both cubes, both are the same. Okay, so this was the last part of the mnemonic device. Both are the same, Basdic, Bobo, Botno, Basdic. All right, and that stands for both are the same, divide the coefficients. Okay, and they mean leading coefficients. Okay, so since both degrees are the same, we're going to divide the coefficients. The coefficients are a 1 on top and a 3 on bottom. Okay, so your horizontal asymptote is going to be y equals 1/3. And that's all there is to it. Okay, so once you figured out which one of those 3 cases we're in, it's pretty fast to find the horizontal asymptote. Okay, so let's try a couple more. All right, so again, we're comparing the degree on top to the degree on bottom. So my degree on top, the highest exponent I have is this 1. Degree on bottom is 2. Okay, so degree is bigger on bottom. Again, highest exponent is bigger on bottom. Okay, so that is the Bobo of Bobo Botno Bazdik, bigger on bottom. And the second O in Bobo gives us our answer. The horizontal asymptote is y equals 0. And again, it would not matter if that was x squared on the bottom or x to the 200th. If it's bigger than the one on top, you don't care how much bigger, the answer is always going to be y equals 0. All right, last one. X squared minus x minus 12 over x plus 2. Again, for horizontal asymptotes, we're just looking at exponents, highest exponent. And in this case, we have the exponent on top. The highest exponent, the degree, is bigger on top. So Bobo Botno Bazdik. Botno means that this is the case where there is no horizontal asymptote. All right. And this one would be one of those functions where you would have that slanted asymptote. So again, I'd encourage you to go for all of these functions on a Desmos and take a look at them and see if our calculation makes sense with what you're seeing with the graph. Okay, last thing that we need to do in a video is to find intercepts, x-intercepts and y-intercepts of rational functions, and we'll do that in the next video.